Morning, doctor.
Morning. Hi. All right. So is everyone here yet? 43, 45. Okay, lah, 50 something. Okay. Okay. Right. I think we can start the class now. So, when's the test? When did I promise you the test is gonna be?
Friday, doctor.
This Friday, right? Okay. So, let me think about it. Yeah. So coming Friday. So coming Friday test. But I may move it to next Monday. We will see. Okay, I may move it to next Monday. Let's see first. Okay, but do you know where the classroom is? When we do face to face, do you know where the classroom is? Makna Lukisan Serbaguna. Do you know where it is? Tahu kan? Di mana? Have you used it before? No, you don't know where it is. Okay, it's in Block B.
Tahu, doktor.
Yeah, it's Block B, Aras Tiga. I will get the lab assistant to send you the location. Yeah, it's at Block B. So it's not Block A, it's Block B, Aras Tiga. There's gonna be a label outside the door. Okay, Makmal Lukisan Serbaguna. So when we have face-to-face lectures or when we have tests, it's gonna be there. Okay. Right. So where do we stop last week? Okay, so we stopped here last week. Then we can look at symmetry. Then okay, we can look at an example. Okay, so today, right? Okay. So for today, I'm going to go through some shortcuts with you. Okay. I'm going to go through some methods of doing shortcuts with you when you have to plot your polar coordinates. All right. So, yeah. Okay. I don't want to draw yet. Okay. So, we learn how to plot. Okay, so so with polar coordinates, all right, we can plot the points. Okay, we can convert the points. Now, at the same time, we can also plot the whole function. Okay, we can also plot the whole function of polar coordinates. All right. So, but before we do that, I'm going to teach you some shortcuts that you can apply. Okay, when you are doing the plotting. All right. So, with polar coordinates, there are 3 rules. Okay. There are 3 rules of symmetry. Okay, that you can use sort of like a shortcut. Okay, when you have to do the plotting. For the first rule is, all right, the first rule is, well, actually, before I talk about the rule, I need to talk about another thing. Okay, so in a polar coordinate, as I mentioned before, okay, you start off from 0 degrees there, and then you go anti-clockwise. You get to 90 degrees or pi over 2. And then if you keep going anti-clockwise, you will get to 180 degrees. Okay, or pi. All right. And then if you keep going, then you get to 270 over there, or 3 over 2 pi. And eventually, you get back to 0 degrees or 2 pi. Okay. So this is the radial system that we follow, okay, in polar coordinates. So there's also another thing that you need to know. So as you can see, this diagram is split into 4 quadrants. So normally what we do is we call this the first quadrant. Okay, so between 0 and 90 degrees, we call it the first quadrant. And then from 90 to 180 degrees, we call it the second quadrant. All right. And then 180 to 270 degrees, we call it the third quadrant. And finally, 270 to back to 0 degrees, we call it the fourth quadrant. Okay, so we call all these quadrants. Okay, we call these quadrants. All right. Okay, so now that's out of the way. Okay. How come I've never done this with you before? Okay. So now that's out of the way. I missed something. Okay, before we talk about symmetry, we need to go through one more example with you. Okay, so so let's forget about symmetry for the time being. Okay, just remember this quadrant thing. Okay, just remember this quadrant thing. Okay, so you have 4 quadrants. Okay, in your polar coordinates. All right. Now let's go through one more example before we talk about symmetry. All right. So last week, before Raya, okay, we've been talking about converting kan. Yeah, we convert from Cartesian to polar and then polar to Cartesian. But last week, what are we converting? We are converting points, right? We are converting points. We are converting coordinates. Yeah. Last week we convert. Oh, I got a point here. In a Cartesian coordinate system, I want you to convert to a polar one. So like that. Okay. Yeah, like that. Okay, I want you to convert to a polar one. And vice versa. Okay. So last week we did conversion. But the conversion that we did last week is point. Yeah, we converted the points. All right. Now, at the same time, if you can convert points, what that means is you can also convert function. All right, you can convert yeah, function of a curve. Okay, so which is what we are going to do now. Okay, so I'll give you an example. So convert r equals to 2 sine theta to Cartesian equation. Okay, so what that means is, so at the moment, this is polar equation. Okay, why? How do you know it's polar?
R.
Yeah, because r and theta, right? Yeah, because of the r and theta. Because there's r and theta. So you know it's polar. So what I want you to do is this function, okay, or this curve, I want you to convert it to Cartesian. So if I convert to Cartesian, what does that mean?
Coordinate.
Yeah, correct. Yeah. Then the equation has to consist of x and y only, no more r and theta. Okay. Okay. No r and theta. Okay. Okay. So I don't want any r and thetas. I only want x and y. Okay. So how do you do so at the same time, if I can give you a Cartesian equation, then you can convert it to back to polar as well. Okay. So you can do it vice versa. All right. Okay. So so let's do this example. Okay. So how do you do this? So remember the how many are 4? Remember the four equations that you can use to convert. So what are the 4 equations that you can use here to convert? Okay, so you have r. So we start with this. So this is the one that we're going to convert. R equals to 2 sine theta. So basically you want to get rid of r and theta and replace them with x and y. So how? Okay, one way you can tackle it is, so at the moment, yeah, there's really not much that you can convert at the moment. Okay, but what you know is, okay, let's go back to the equation last week. I'm gonna scroll back. Where's the 4 equation last week? There. Remember these 4? 1, 2, 3, 4. From last week. Yeah. So we are going to have to use these equations, okay, to do our converting. Okay. So how are we going to use these 4 equations to do our converting? So we have one r. So we have a single power r here. We have 2 sine theta on the other side. Okay. Not much you can do, but we know that from the previous 4 equations, you have an equation, right, which is r squared you have an equation 4, which is r squared equals to x squared plus y squared. Yeah. So we have this one which we can use. So to be able to use this, we have to turn our r into squared. So to turn our r into squared, we have to multiply with another r on the left hand side. So that means you have to multiply r on the right hand side juga lah. Okay. So then that gives you r squared equals to 2r sine theta. Okay. So you know now r squared is equals to x squared plus y squared. So we substitute equation 4 in. X squared plus y squared equals to 2r sine theta. Okay. Okay, so the left hand side is x and y sudah. So it's only on the right hand side we still have r and sine theta. What equation can we use? What other equation can we use? R sine theta is what? You go back to the 4 equations. R sine theta is what?
Y over
R sine theta is what? Look back in your
Y.
notes. Yeah, it's y, guys. R sine theta is y. Yeah. This is from, I don't know, the number 1 or number 2, I can't remember. Okay. R sine theta is y. So you can substitute y with r sine theta. So that gives you x squared plus y squared equals to 2y. So you bring your y to the, we bring everything to the right hand side. That's what you get. And then can you factorize? Well, x you cannot lah. X you cannot. Y can you factorize? Can you factorize y? How do you factorize y? Someone factorize for me. What do you get when you factorize y? Quick, how? How to factorize this? Okay. Okay, everyone listen. Actually, so factorizing, you're supposed to know. You're supposed to know how to do factorizing. Okay. But for this one, for this example, I will show you. Okay. In the future, you have to know how to do it. All right. Okay. How do you actually factorize? Use another color. Use green. How do you factorize this? Y squared minus 2y equals 0. How do you factorize this?
y minus 2.
Yeah. Y minus 2, so you take y out. But what if I want it in the format macam ini? Squared. How do you do that? You still remember? I think you've learned this before, right? Okay. So the way you do it is, so actually right at the moment you cannot factorize. Normally when you factorize, it's like that. And then you get some number there. Baru you can factorize. What is that number there? Well, normally when you factorize something, it's like that. X squared plus 2y plus maybe 4 equals 0. If it's like that, do you know how to factorize? If it's in that format, do you know how to factorize?
Yes, doctor.
Yeah. So without that last number there, do you know how to factorize?
No.
Okay. So the problem now is we need to find that number. Okay. We need to find that number. How do you get a number? How do you get that number? How do you get that number? So yes, so you're right. Okay, so you're right. Without that last number, that 4, you actually cannot factorize it. So you have to put that 4 in. You have to find that number in there. Then baru you can factorize. But what is that number? How do you get a number? So the trick here is, how do you get a number so that you can do your factorizing? Okay, so in this case, I can tell you lah. Okay, in this case, it's actually 1, positive 1. Okay, but if you put positive 1 there, you have to put if you put positive 1 on the left hand side, you have to put another positive 1 on the right hand side lah. Okay, then only it's balanced. Okay, but how did I come up with this positive 1? Do you know? Where this positive 1 comes from? Dari mana? Well, how do you know? How do you know what number to put in so that you can factorize it? You cannot simply put any number. You put 2, it doesn't work. You put 3, it doesn't work. You put 4, it doesn't work. It only works if you put in 1. Okay, so if I put in 1, then when I factorize, what do I get? Now I can factorize, right? It's y minus 1 squared. Betul kan? Done. Yeah. Okay, and then on the right hand side, you still have the 1 there lah. So you have to keep that 1 there. Okay, so the trick is, how do you get that 1? Okay, why not 2? Why not 3? Huh? Okay, it's something to do. It's actually related to. It's actually related to this negative 2 here. Okay, you have to think about it. It's related to that negative 2 there. Okay, you think about it. I'm not going to give you the answer. Okay, you try to find out why. How do I get this? How to get this number so that you can factorize it. Okay, but basically, to factorize it, you have to put plus 1 on the left hand side and then plus 1 on the right hand side. Then it allows you to factorize it. Then that's the answer after you factorize. Okay, but you find out how I get the 1. Okay, you find out on your own. All right. Okay, so once I factorize, then it's y minus 1, okay, squared, but I have a 1 on the right hand side, so I have to put that 1 in there. All right, so that's the answer. Okay, so this is the final answer. So then what you can do then is you can plot this is now a curve. This is now some sort of a curve. Yeah, because you have x squared and y. Okay, you have x squared and y in there. So, well, yeah. If I have x squared on one side and y on the other side, what type of graph is this? Well, it's some sort of like a U-shaped gun. Agree?
Yes.
Yeah. So it's some sort of a U-shape. Okay. So you can start guessing the shapes of that. Okay. But for this one, we are not gonna plot the shape lah. All right. In the later example, we're gonna plot. Okay. So as you can see, polar coordinates, you can turn it into polar equations, and then you can start plotting for curves as well. Okay. So that's the important point. But there are shortcuts that you can use when you plot these curves. Okay. So you can check for symmetry. Okay. You can check for symmetry. This is a shortcut lah. You don't necessarily have to use it. Okay, this is a shortcut. All right. So let's say you have some function of theta. So yeah, you have some function r equals to some theta. Okay. So if you can do a check, if the function when the theta is positive is equals to the function when the theta is negative, what that means is the function is symmetrical about the polar axis. Okay, so the polar axis is the 0 to 180 degree axis. Okay, I will draw it here. Yep, so this is polar axis. Okay, that is the polar axis. So if you can do a check, you can prove that if you put a if the theta is positive, when the theta is positive, it gives you the same answer as when the theta is negative. What that means is, for that function, whatever is happening on the whatever is happening on one side of the polar axis, it's symmetrical about the other side as well. Okay, so you get the same shape, top and bottom. Okay, what that means is you get the same shape lah. Yeah, let me just write here. Okay, same shape, top and bottom. Okay, later I will show you how you do this check. But at the moment, you just remember this rule. Okay, just remember this rule for now. Now there is a second rule. If pi minus theta equals to theta, that means it's symmetrical about the pi over 2 axis. So what that means is, what's the pi over 2 axis? This is the pi over 2 axis lah. Okay, this is pi over 2 axis, the vertical axis. Okay, so what that means is, whatever happens on one side happens on the other side as well. So what that means is you get the same shape left and right. Okay, you get the same shape left and right. Okay, so you see why this is a shortcut? Can you see? So it's a shortcut because what that means is, let's say the first rule. Let's say you check for the let's say you do the check based on the rule number 1 lah. Okay, so what that means is you only have to plot the points from 0 degrees to 180 degrees. So you just have to do 0 to 180 degrees. You get the shape on top, you can mirror the shape at the bottom. Yeah, so you don't have to plot all the way from 0 to 2 pi. You just have to plot from 0 to pi. Whatever shape you have, you get, you can just mirror it below. Okay. So the second rule is the same, except it's left and right lah. Okay. And then there's a third rule. So the third rule is, if if 5 pi plus theta equals to theta, then it's symmetrical. About the pole. Okay, so where is the pole? This is the pole. The center point, the middle of the crosshair. That is the pole. Okay, so if your function fulfills this rule, that means it's symmetrical about a pole. So what that means is whatever shape you have in the first quadrant, or whatever shape you have in any quadrant, it will be repeated in the second quadrant, third quadrant, fourth quadrant. Okay, is that clear?
Yes.
Okay, so if that's clear, then we do one example. Okay, so at the moment we've only been having our classes online. Yeah, at the moment we've only been having our classes online because, well, for the first few weeks, puasa, so that's why we did it online. And some of you want to go back for Raya, so that's why we did it online. Okay, so online is fine for me. But I'm worried that some of you have trouble paying attention if I do it online. Okay, so I'm going to use test one. So test one, maybe Friday, maybe Monday. I don't know yet. I'll let you know later. So I'm going to use test one to judge, to basically see whether how effective online teaching is. Okay, so if the average test performance isn't that good, then I will switch everything to face-to-face. Then you have to come into class every Monday and Friday. Okay, so make sure you pay attention in class and do well in the test. Okay, if you do well in the test, then we can have more online classes. Then you don't have to come into the, so that means you can online from home lah, basically. You don't have to come in early in the morning. Okay, if you don't do well in the test, then I will mix online with face-to-face class. Okay, sometimes we're gonna have online, sometimes we're gonna have face-to-face. Okay, if the overall performance is really bad, then I'm going to fully switch to face-to-face. So all the classes will be face-to-face. Okay, so even though this is, so even though at the moment we are having online class, I hope you pay full attention. And if you have any questions, you can ask me straight away. Don't wait until the night before the test to ask me. Okay, if you have any questions now, you can ask me now, because all the time I'm just going through examples. Yeah, I just go through examples. So if you don't understand any aspects of the example, you can ask me straight away. Okay, don't wait. Okay, right. So so these are the 3 rules that you can apply as a shortcut. Okay, you can use this rule if you want to save time, or if you don't understand how to do it, then never mind. Then you don't have to follow these rules. You can do the long way as well. Okay, this is just, these 3 rules are just shortcut methods only. Okay, you can choose to use it, or you can choose the long method, the longer method as well. Okay, so now I'm going to have an example, and I'm going to show you how to do this rule. Okay, right. Okay, example. Right, so r plus equals to 1 plus cos theta. I want you to plot this equation. Yeah, so this function from 0, yeah, to 2 pi. Okay, so this, it has r, it has theta, therefore it's polar. Huh? It's polar. I want you to plot from 0 to 2 theta. How do you plot it? Okay, so 2 methods. There's a shortcut, there's a long cut. Okay, so we do the long cut first. We do the long method first. Okay, so there are 2 ways of doing this to plot. There's the long method. Can you guess what is the long method? Okay, so method 1, long method. Guess the long method. Hey, how to plot the point? If
But
r is equal to 0, then what is? Oh, sorry. Yeah, if theta is 0, then what is r? Basically, that's what you do when you plot. Yeah, same as x and y. So basically, you draw a table. Yeah, you draw a table. Basically, very long table lah, because you want to do because we are doing the long method right now. So it's going to be a very long table. At the top, it's going to be yeah. So if you look at the question, plot from 0 degrees to 2 pi. Ini apa? 0 degrees to 2 pi is what? R or theta?
theta.
Yeah, correct. Theta. So what that means is I want you to plot all the points for theta 0 degrees all the way to 2 pi or 360 degrees. Yeah. 2 pi is 360 ma. Yeah. So when you plot, basically you put theta in, you should get R as an output. Okay. That's basically what you're doing. Okay. And then you just plot the points like how I taught you last time. Okay. So so let's try. Let's try a few. Okay. So what do you want to try? Okay. I tried 22.5 lah. 22.5 is what? Pi over what? Pi over 8 kah? Yeah, pi over 8 or pi over 3, I don't know. Yeah. Then maybe you can do 30 degrees juga. Then maybe you can do 45 degrees. Then maybe you can do 60. Then maybe you can do 90 degrees, which is pi over 2. Then so on and so forth. And then you can keep going. You can keep going. And then maybe at some point you're going to get pi. Lepas tu you keep going. And then you get to pi is what? 180 kan? Yeah, 180. Then you keep going, you try a few more points, and then you get to 3 over 2 pi, which is 270 degrees. And then you keep going until you hit 2 pi, which is 360. Okay? So as you can see, it's a very, very long method. Okay, you have to try all these points. Okay, let's do 0 degrees first. Okay. When theta is 0 degrees, what is R? Quick.
2.
Yeah, 2, correct. Okay, when it's 22.5, 1.9 gun, something like that. Agree?
Yes.
When it's 30 degrees, when it's 30 degrees,
1.15.
1.15. Okay. When it's 45 degrees, at 1.15 ka?
1.86.
1.86, huh? 1.86 is 30 or 45? I don't know. I don't have the answer. Tell me. 1.86 is 30 or 45?
80.
Huh?
55, 1.7.
Okay, 45, 1.7. 45, 1.7 ka? Okay, 1.7, 1.71 lah. Yeah, because it's technically 1.707. Okay, so 60 degrees, how much?
1.5.
Okay, 1.5 and 90 degrees.
1.
Okay, 1. And after 90 degrees, what do we want to try? 90 plus 90 plus 30 is what? 120. Okay, try 120. Maybe sekejap. Try 100 lah, 100. Eh? Oh, sorry. 90 plus 22.5 is what? Ninety plus 22.5. 102.5 ka?
112.
Yeah, okay. So try 102.5 and then maybe try 120 and then maybe try, I don't know, 150 and then maybe try 180. Okay. Yeah. What is 102.5?
0.78.
Okay. What is 120?
0.5.
Okay, 0.5. What is 150?
0.13.
And what is 180? 0. Yeah. Okay. So you can see how painful this method is. Yeah. It's a very, very painful method, right? Basically, we haven't finished yet. You have to do all the way to 360 degrees. So we've gone halfway. Okay. We gone halfway, Sudah. But you have to continue. Okay. You're supposed to continue all the way to 360 degrees. Okay. So then how do you plot it? So let's say, imagine you've done it to 360 degrees. Okay. How do you plot it? So the way you plot it is, well, you've done it before, right? How do you plot polar coordinate? Yeah. So the way you plot polar coordinates is, okay, so at 0 degrees, it's 2. So 0 degrees, it's there. It's that flat line there. So 2. So you measure 2 lah. 2 maybe there. Next, you have 22.5 degrees. 22.5 degrees, how do you plot? Use protractor. So you put a protractor here. You measure 22.5. Okay, you measure a line from 0 degrees. You get a line which is 22.5 from the flat axis. Okay, from the 0 degree axis, and then you measure 1.9. 1.9. Maybe it's there. Now, be careful. The 1.9 is not the horizontal measurement. It's not that measurement. It's not. The 1.9 is not this. The 1.9 is this. It's the radius. Okay? Be careful when you measure that 1.9, the R. The R is not along the x-axis, it's along the the slanted axis, the angle that you draw. Faham tak? Ya. Semua yang lain faham?
Understood.
On
So there, 1.9. I have to delete lah. Later it gets very crowded. So I have to delete the 1.9 measurement. Okay. Next, 30 degrees. How do you draw 30 degrees? Same. You take a protractor, you measure 30 degrees, and then you take your ruler. It's 1.86. So you measure 1.86 there. So basically you basically keep doing this. And then say 45 degrees, you draw 45 degree. And then it's 1.71. It's there. Next, 60 degrees, you draw 60-degree punya line. And then it's 1.5. Maybe it's there. Next, pi over 2. Okay, pi over 2 is 90 degrees. It's that vertical line there. Oh, it's 1. Okay, maybe it's there. And then 100, 0, 2. It's maybe that one there. It's only 0.8. So it gets shorter. So that line gets shorter and shorter. Okay, and then when it's 120 degrees, it's 0.5. And then when it's 150, it's even smaller. And then finally at 180, it's 0. 0 is where? There lah. 0 is there. It's the origin. That's 0. So now we have plotted from 0 to 180 degrees. So you can join the line. So you just join. So you start here. I'm gonna use green color. Okay, so now you can join the line. Okay. But this line is from 0 to pi only. This line is from 0 to 180 degrees only. You still have to do the rest from 180 to pi. I don't know what it's going to look like. Okay. Then you're going to do your find angle here, 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 find angle here. Then I don't know what it's going to look like lah. Okay. Can you finish this? Okay, I give you 10 minutes. I give you 10 minutes. I want you to do the rest. I give you 10 minutes. I want you to do the rest. Maybe you can try after 180 should be what? Plus 30. 180 plus 30 is what? 210 kan? Yeah, 210. And then plus 30 is what? 240. Plus 30 is what? 270. Plus 30 is 300. 330, 360. Okay. So try all these points. And then plot the rest. Okay. I give you actually 5 minutes enough lah. 5 minutes enough, but I give you 10 minutes. Okay. I give you 10 minutes. You plot all these points. You tell me what the rest of the graph looks like. Boleh tak? Boleh?
Can.
Okay.
boleh.
Okay. 10 minutes. All right.
Yes.
Why? Everything okay? Why you sound so demoralized?
Everything's fine.
Everything's fine, yeah? Okay. Any complaints? You can let me know. Anything you're not happy about? You want to pour your heart out? You can share with me. I can give you advice.
Not yet.
Not yet, huh? Okay. Yeah, it doesn't have to be related to calculus, can be anything. Relationship issues ka, love issues ka. Everything okay ka?
Oh, fine, doctor.
Oh, fine, huh? Okay. All right. All right. Yeah. Okay. So yeah, but really, if you have any issues, you want to talk with someone, you can always look for me. Okay. Just not at night. Okay. Look for me during daytime. Okay. If you have any issues, then I can maybe point you in the correct direction. Okay. Right. So, so have you tried to plot all the remaining points? Can you see my screen?
Yes, can.
Okay.
Yeah.
Okay. Have you done the rest of the points? What does it look like?
A heart shape.
Yeah, correct. Yeah. So you actually get the same shape at the bottom. Like that. Okay. Yeah, so if you look at it from the side, yeah, correct, then it looks like a heart shape. Yeah. Okay. So this is method number 1. This is the long method. Okay. Now, alternatively, we can do the short method. Well, short-ish lah, not very short, but I think it's a bit shorter than the first method. We can try the short method. So how do you try the short method? Okay, so to try the short method, basically you need to look into these 3 rules that I talked about earlier, the symmetry Pinel rule. Okay, you need to look into the 3 symmetrical rules, which will hopefully help you save a bit of time. So I will teach you how to do that. Okay, so everyone understand? So if I give you a question like this, I ask you to plot from 0 to 2 pi, you can use the long method, which is you plot all the points and then you draw the shape. Okay. Oh, I forgot to mention one thing. So after you plot this, normally what I want you to do also, I didn't mention it in the question, but normally what you have to also do is you also have to show the starting point, the initial point, the terminal point, and also show the direction. Yeah. So normally you also have to show initial point, the terminal point, and the direction juga. Okay. So initial point is the starting point, 0 degrees. The terminal point is 360 degrees. Okay. So initial point is 0 degrees. It's there. The terminal point is at 360, so it's there. So the direction is here. That's the direction. Okay. So normally you have to show all this as well. Okay, in your graph. Okay. Okay. So that's the long method. Okay. Very straightforward. Okay, easy to understand what's going on. Okay, so now let's try the short method. So for the short method, you have to check for symmetry. Okay, for the short method, you have to check for symmetry. So when you check for symmetry, there's 3. There's 3 symmetry you can check for. You can check for symmetry about the polar axis. So this is where Yeah, this is where you check that negative theta is equals to positive theta. Yeah. Negative theta is equals to positive theta. Okay, so what's our function? Our function is r equals to what's that? Well, 1 plus. Okay, 1 plus cos theta. So this is our question gun. Yeah, r equals to 1 plus cos theta. All right. So how do you check for this symmetry? Negative theta, positive theta. Basically, you just simply choose one theta and you try. I'm going to choose 45 degrees. I'm going to try a theta of pi over 4, which is 45. Yeah, 45 degrees. Okay. So basically what this is saying is, so I'm trying a theta of pi over 4. Okay. So basically what this is saying is, when you put in negative pi over 4, you should get the same answer as when you put in pi over 4. Okay, so let's try. So when theta is negative pi over 4, what is r? It's 1 plus cos negative pi over 4. Okay, what is this? What is cos negative pi over 4 plus 1? Quick. Apa jawapan dia?
1.71.
Yeah, 1.71. Okay, when theta is positive pi over 4, what is r? Yeah, so now I'm trying positive. I put it's positive in there. What is the answer? Also 1.71, right?
Yes.
Okay, so therefore you can see when theta is negative, you get the same answer as when theta is positive, right? Correct?
Yes.
So what this is telling me is this function is symmetrical about polar axis. Okay, so this function is symmetrical about the polar axis. What that means is what shape you get on top, you can mirror to the bottom. Okay, they whatever happens on top is mirrored at the bottom. Okay, so we've done one check. Let's do the other check. For completeness lah. For completeness. Okay, so now we check for symmetry about the vertical axis. Yeah, the pi over 2 axis. The pi over 2 axis. So for this one, the rule is this. Minus theta equals to this. Okay, so again, let's try a theta of pi over 4. Let's try a theta of pi over 4. Okay, so we know that when theta is pi over 4, r is 1.71. Okay, so when theta, when the angle is pi minus theta, so pi minus theta is pi over 4, what is r? So it's 1 plus cos pi minus theta. Okay, what is this? Pi minus pi over 4 cos is what?
0.0 29.
Okay. Okay. Now, is 1.71 the same as 0.292? Tidak kan? Yeah. So R theta is actually not the same as R pi minus theta. Yeah, because R theta is 1.71. R pi minus theta is 0.29. Yeah, it's not the same. Therefore, if it's not the same, it's not symmetrical about the vertical axis. So that means when we do this check, we want to see whether whatever we have on one side, whether it can be mirrored on the other side or not. Yeah, whether it can be mirrored on the other side or not. So in this case, I show that it's not symmetrical, right? That means it's not mirrored. Yeah, it's not mirrored. That means you cannot apply this rule. The second rule cannot be used. Okay. So let's check the third rule. The third rule says what? Check symmetry about the origin. Okay, so for this one, what is the rule? Pi plus theta. Is it? Yeah. Pi plus theta equals to theta. Okay, so again, let's try. Let's try a theta of pi over 4. So we know when this is pi over 4, it's 1.71. When pi plus pi over 4, what is the answer? 1 plus cos pi plus pi over 4. What is this? What is cos pi plus pi over 4? Plus 1. Anyone?
0.29.
0.3?
29.
29. 0.29 as well. Okay. But the point is this. I don't know whether, yeah. Okay. The point is, what I've proven is it's not equal to this as well. Yeah. It's not equal. Therefore, it's also not symmetrical. About origin or about the pole. Okay. So when we do this check, I want to see whether we can find the shape in one quadrant. Yeah. When I do this check, what I actually want to do is I want to see whether I can just draw the shape, just plot the shape in one quadrant. Because if it's symmetrical about the pole, what that means is I only have to find the shape in one quadrant, then I can mirror it to all the other 4 quadrants. But unfortunately, it's not symmetrical. Therefore, I cannot apply this rule. Okay? If it's symmetrical, then it will save me a lot of time. I just have to look for the shape between this. Ya? Ya. Ada soalan nggak? Ada soalan?
No, doctor.
Okay. All right. Okay. So the third rule cannot be used. Second rule cannot be used. The only one that can be used is the first rule there, because only the first rule is symmetrical. Yeah, it's equal. So the first rule says what? Whatever I get from 0, yeah, basically the top shape can be mirrored to the bottom. What does that mean? That means, okay, so only the first rule can be used. So the first rule says, whatever I get at the top, I can mirror to the bottom. Correct? Correct, right?
Yes.
So what does that tell you? What does that tell you? That means you only have to look for the shape between 0 degrees to pi saja kan? Because you can mirror to the bottom. Betul tak?
Yes, betul.
Because you know whatever happens on top is mirrored to the bottom. Okay, so then using the second method, what you only have to do is, because you know you can mirror it, then you only have to look for an angle of 0 to pi saja. You don't have to go all the way to 2 pi. Yeah, you only have to look for 0 to pi. You don't have to do all the way to 2 pi. Therefore, then you will get this answer. If you do 0 to pi, you will get this shape. Salah. It's actually more like, yeah, something like that kan. Yeah. So you only have to find 0 to pi. You will get this shape, and then because you know it's symmetrical about the polar axis is this. Then you can draw the exact same shape at the bottom. Okay. So this is the shortcut method lah. All right. Okay, now any questions? Any questions? Is that clear?
Clear.
Clear, Doctor.
There.
All right. Now another so if that's clear, we do a similar example. So another polar equation. Okay. Okay. So same question. So yeah. So same thing. So here we have another example. So yeah. So we have another example here. Except the question, the function is a bit different. Okay. But the things I want you to do is the same. Yeah. Plot this function from 0 to 2 pi. Show the initial point, termination point, as well as the direction. Okay. Now for this one, for this question, a little bit special. I want you to check for symmetry first. Check for symmetry about polar axis. The pi/2 axis, the vertical axis, and as well as the symmetry about the pole. Okay, so I want you to do all three checks first. Okay, then you plot. Okay, can you do this on your own? Then on Friday we discuss if there's no test. Okay.
Okay, Doctor.
Okay, so do this on your own right now. 20 minutes left. You have 20 minutes left for the class. You do this on your own. We will discuss on Friday or Monday, depending on when the test is. Right? All right. I'll see you on Friday. Make sure to do the attendance. I've shared the link. I've shared the link in the chat box. All right. Okay. See you on Friday.
Okay, see you, doctor. Thank you.
Okay, doctor.
Uh,
Thank you, doctor.
Doctor.
Thank you, doctor.
Thank you, doctor.